In these sessions, we are going to discuss about the design thinking for biodegradable polymers. So, the biodegradable polymer is the emerging technology for the packaging material in the industry level and domestic level. So, now let's open for the discussion for the DT-based biodegradable polymers.
Empathy. Empathy, understand the users need. Understand the impact of plastic that affect the users. We can conveniently use the PVA biodegradable polymer that helps to degradable naturally that does not affect the land and the soil. The plant's soil pollution will be reduced, air pollution, water pollution will be reduced.
So, what are the existing technology for the packaging material? Anybody tell about there is a conventional packaging material, there is a polyethylene. So the polyethylene material is hazardous. So the very early stage, we are constructively used for the best invention. So after that, nearly 3 to 4 decades, we use it after usage of the conventional polymers. It cannot easily degradable in the soil and water. Okay, there is a big impact on the pollution aspect. So we go for the alternative technology. So the empathy is of this DT-based biodegradable polymer is very interesting. Next, different. Sound. So mostly the traditional polymers is always using the polyethylene polypropylene. That is the thin film technology. Thin film means the very thin thickness is very less. Okay. So that is after usage we disposed in the land or water. It creates pollution. So that you define exactly why we go for it for this kind of biodegradable polymers for the traditional packaging. So that is interesting. Okay. So we go for the natural or biodegradable polymer material. Fine. Next.
In our stages, I need think of many biodegradable product ideas. Explore many ways to strengthen biodegradability compared to natural materials like starch.
Exactly. So not only the PVA is available, industrially available, and mass production also. This kind of material is available everywhere. But we go for another natural polymers, starch, cellulose. So that can be incorporated in the polymer be better property. There's a mechanical property and also the flexibility. So many advantages while adding the incorporation of cellulose and starch, natural starch. Okay, that is very much interesting. So that is next point.
The fourth stage is prototype. The prototype of polymer is initial sample and model made from polymer material. Material to test the design, production, structure and shape before mass production. The biodegradable polymer can be broken down into natural substances.
So the preparation of the polymers is easily breakdown. So already showed that material. So the first without adding any additives, it comes to the easily shrinkage. That is a PVA-based polymer. So we add the citric acid, other additives to improve the better formation of the film. Okay. So the prototype steps we include for the various kind of additives. Even starch also, starch, cellulose, that's an additive. But we go for the plasticizer. Plasticizer means that is a good flexibility. So then bond formations. So that kind of property we can improve adding the citric acids and other materials also. It helps to make it for the better bonding. Okay, so that it helps to the similar to the conventional or traditional packaging material. Okay, so without the adding the additives, we can't do for the packaging material for the PVE material. Okay, so that's good. So prototype steps. So we are modify the different approaches, the PVA with other materials. Okay, to improve the mechanical property, other kind of industrial importance properties. That is similar to meet out the traditional packaging material. Fine.
And the final stage is testing. Try this prototype in real life conditions. Test for how fast it degrades in soil, water, and sunlight. Test for durability during handling and transport. And we should receive user feedback. We should identify the improvements in the testing. Improvement of biodegradation rate, increasing mechanical strength, reduction in cost, increasing water resistance.
So the testing is we confirm it whether meet with our requirements. So we compare with the conventional or traditional packaging material. Okay, how can we compare? So we compare with the existing packaging material. Okay, so in this aspect we are going to characterize the material. So after preparation of biopolymers, so we go for XRD and contact angle and FTAR and XRD. So these are the different kind of testing. So we confirm it, so meet out our requirements. If it is meet out, so the characteristics are very important. And also biodegradability and backlight. So many factors are there. But we mainly focused on XRD and contact angle and FTAR and scanning electron microscope. So this kind of the material property is very, very important to ensure our quality of our biodegradable polymers. So any conclusions? So why we are discuss about this kind of biopolymers? So only thing is we avoid the pollution. Okay, like soil pollution and water pollution. So the conventional method or traditional methods, it is a practicability. We are facing a lot of trouble. Even we'll go for even the degradation approaches, incinerations also liberation of the unwanted gases. So that also it creates air pollution. So finally the concluded the DD-based the biodegradable polymers, it is useful for the customers. That means all the people. Okay. Thank you.